afternoon, I shall say. How's everyone doing? Thanks for having me here. My name is Mu'taz Abdullah. I'm a division manager at AESG. We are a Dubai-based company. Just one slide about the company. We're a specialized consulting and commissioning firm. We specialize in environmental, commissioning, facade engineering, fire and life safety, sustainability, and energy management. Some facts and introduction. Well, globally, the tourism contributes to 5% of the global carbon dioxide emission, and it was named by the United Nations Environmental Program as one of the top 10 in the transition towards green economy and sustainability. And also the United Nations declared the year 2017 as the International Year of Sustainable Tourism for Development. And that's why recently we do see a lot of emphasis in new construction projects when it comes to the hospitality industry. In new construction projects, all the green building rating system have a separate category for hotels or for hospitalities, and we do see a lot of applications of environmental management during design and construction, facade engineering, and envelope verification, especially when we're talking about lead commissioning and Istidama and GSAS commissioning, commissioning management, and energy modeling and sustainable design. For existing infrastructure, the Emirates Green Building Council has conducted a study last year, and basically what they've done, they have taken they've invited about 75 different hotel properties, and they've received feedback, or basically 46 properties volunteered to provide their information to conduct this benchmarking study. Some of the data collected were the monthly energy consumption in terms of kilowatt hours for the past 3 years. I'm talking 2012, 13, 14, and 15. The monthly chilled water consumption for the district cooling facilities, the water consumption, the guest night, and monthly occupancy per month. Some data normalizations were done to account for the cooling degree days between the different cities. And the district cooling consumption also was converted to kilowatt hours. Some of the factors that could impact the study were looked at. Those factors are like hotel size, number of rooms, and type of facilities. The outcome, I'm not going to get too much into details of the study, but this is the outcome. The normalized energy utility index in terms of kilowatt hour per meter square per year, the data were ranging between 104 and 721, and that's a huge range. But further analysis were done. An average of the median value was 283 kilowatt hour per square meter per year. Doing further analysis for the kilowatt hour per guest night per year, which is more relevant for the hospitality industry, data were ranging between 26 and 336 kilowatt hour per guest night per year across the examined hotels, and the average was about 94. Water consumption. The water consumption, again, was ranging between 30 and 399, and the value, or the average value, was 136 imperial gallon per guest night per year. So some of the global benchmarking systems or tools available are basically the GigaGoals and Energy Intensity Calculator, which is used in Canada, the EPA's, the Environmental Protection Agency's Portfolio Manager in the States, and the European Energy Performance of Building Directive in Europe. Some of the rating certifications, of course, LEED, BREEAM, and Energy Star. Talking about Energy Star is basically a program to certify buildings and products based on their certain standards and based on their energy efficiency. And to be certified, for a building to be certified as an Energy Star building, they have to achieve a score of 75%, which means that they are above 75% of similar facilities. And Energy Star rating is between 100 and 10. And funny that recently the United States administration, they have proposed cutting all fundings to the Energy Star program, which is run by the Environmental Protection Agency. And I think this explains the reason. If we track some of the high-profile Trump facilities, we're looking at their Energy Star, the Trump International Hotel Tower in Chicago. It's an Energy Star rating of 9 out of 100. The Trump International Hotel and Tower in New York, an Energy Star of 12 out of 100. So this is really a bad example. So if you're shopping for that brand, please do not. So do I need to benchmark, or do I have to benchmark? So currently there is no mandate. There's no mandate that asks you to do a benchmarking. And the reason for that, because there is no mandates to disclose energy consumption data in the region. In other places, there are mandates. So those mandates will soon be in the region, and at some point, everyone will have to disclose their energy consumption to the government or to an authority. So what do I benchmark against? Currently, there is no solid system in the region, but again, we could always do it through the Energy Star and do some normalization for the cooling degree days. And let's say that we have done the benchmarking for an existing facility. So what do we do? What's next? So after doing the benchmark, a detailed utility analysis needs to be done to understand where the current scenario or where you stand, by conducting historical analysis, doing a regression analysis for occupancy and for the weather. And from there, it would be important to set your goals, develop your initiatives, get all the stakeholders involved. Stakeholders could be the operator, it could be the service providers, and develop a business as usual model for your energy program. So in this example here, we've got a property with spending of 30 million, let's say Qatari Riyal, for example. Doing the business as usual by 2030, that could move up to 50 million per year, and this could be for reasons for expansions, optimized occupancy, or a deterioration in energy consuming systems. So you need to look at that and be reasonable the way you set your targets. So looking at the orange line here, this is basically developing an energy management program with a 24% saving against the business as usual model by 2030. So the energy consumption is still slightly increasing. However, you're still saving 24% from the business as usual. Next step would be implementing an energy audit, which is basically conducting system surveys, conducting measurements for the major energy consuming systems, data logging, and developing ECMs, energy conservation measures, developing the saving calculations and the feasibility of their application, and the ROI model. The energy saving initiatives could be in lighting, water, HVAC, renewable energy, chiller plants, and any energy consuming system within the facility. And there's a lot of options. Just if you look at the chiller plant itself, you find that there's a lot of options within the chilled water distribution system, within the control system. There's many options on the air side that can be looked at. This is a fact on emission reduction opportunities. And what I would like to highlight on this, the difference between the demand side and the generation side. So by focusing on the energy consuming systems and reducing the current consumption, you're not only reducing your greenhouse gas emission, but you're also generating an investment opportunity. Where those type of measures typically pays for themselves quicker than those measures on the right side. We're talking renewable. This is the energy saving measures spectrum within the energy efficiency. So if we look at the short-term ECMs or energy conservation measures, we'll be looking at between 0 to 2 years, we're looking at just building systems optimizations. This is low-cost measures. Moving into 2 to 4 years, we're looking at some retro-commissioning, Small enhancements could be in the range of 4 to 6. If we're talking central plant optimization, then again we're at 6 to 8. Central plant retrofit, chiller replacement, it could be 8 to 10. And as we move up to the renewable energy, we could be talking 15 years or more. So after doing the energy audits, developing the energy conservation measures, now it's time for implementations. And there are various ways to do these implementations. The most obvious way is to do the segmented approach, where basically a hotel will directly contact their suppliers or service provider and conduct isolated retrofits. Another model, if we're talking about a bigger retrofit, is energy performance contracting. And with energy performance contracting, there's two types of, there's the guaranteed saving and there's shared saving. Within the guaranteed saving, that's basically where we have an energy service company will take on the retrofit, guarantee the saving for X number of years, and over the term of the agreement, that those energy saving will be guaranteed, and if any shortfall payments happens, then the ESCO will have to pay back the hotel or the customer. A shared saving model is slightly different. In a shared saving model, we will have the ESCO or the energy service company act as an investor. They will invest in the ECMs, and they will take their money back from the saving. On a shared model, could be an 80-20 or 90-10, or it could even be 100%, and then the client will enjoy the saving after the payback period. Some of the energy efficiency trends currently in the market is data analytics. With data analytics, currently every building has a BMS today, whether it's working, whether it's fully commissioned or not. There's a lot of data is coming to the BMS. Those data are coming from meters, sensors, data loggers. It's coming to a centralized BMS. And all it does is basically start, stop, programming, could be giving alarms. But there is a need to do some benchmarking within a group of, or one type of equipments, and to create some sort of fault detection tools to further enhance the BMS system and to further utilize the BMS system and save energy. Some of the tools that you could find in these type of softwares or programs is a carbon and energy reporting. And what that gives you, basically gives you a high-level enterprise view of the utility usage, cost, and equivalent greenhouse gas emission. A more sophisticated one is the measurement and verification tool. And what this tool allows you to do is to monitor each retrofit separately and to adjust the baseline accordingly based on your occupancy and the weather. There is also a custom-made type of analysis where you do some trending and runtime for chiller AHUs pumps. And there is a continuous diagnostic tool, which is a more interesting tool. It basically configures and prioritizes the type of faults. And I'm going to give an example here of a set point of 23, where there's a threshold of plus or minus 1 or 2. In this case, it's +1, -2, where you'd have an alarm above 24 or below 21. So if your actual set point keeps fluctuating within those alarms, within the threshold, you will never get an alarm in the BMS and everything is going to look great. However, this custom tools, it allows you to do some sort of faults or detections to basically to identify if your set point has been fluctuating between so and so for X amount of time. That means something is wrong, and it could be a commissioning issue that needs to be looked at. Well, anyway, this is definitely an energy saving opportunity. It could be done on the AHU side. It could be done on the chilled water side as well. So just to summarize this, there is a significant scope for improvements in energy in new and existing facilities. On new facilities, it comes in terms of sustainable design, passive energy strategies, modeling, energy modeling, and developing different scenarios and application of ECMs within the energy model. And within the existing facilities is basically understanding your current consumptions, patterns, and developing your initiative plans and implementing those plans and conducting the measurement and verification continuously. With that, I'll conclude my presentation. Thank you so much. Any questions?
I just need a definition for guests per night per year.
This is basically the number of stays.
No, if you say consumption of anything, guests per night per year, that means what?
This is the total consumption divided by the number of stays of guests. So for example, you have a hotel room with 100 rooms. Those 100 rooms were utilized about 10,000 times a year. So this is 10 stays. This is 10,000 stays. So you divide the total consumption by 10,000.